Okay, so welcome to the NEP for repeated transformations. So your title is repeated transformations, and then we've got notes, examples, and practice questions. So turning to your notes books or your folders or your notepads, wherever you're doing your notes, that's your title, and then we're going to write the notes. Now the notes say, apply transformations by following BIDMAS. So you stretch, which is the multiplying, and then you do the translations, which is the adding and subtracting. And remember those key words. So we need to use those words stretch and translate when we're describing transformations. It then says apply transformations inside the brackets first. Again, that makes sense following what we know about BIDMAS. And then our little blue box is just a bit of a recap on the modulus function. So there are two NEPs on the modulus function. This is the modulus of the entire function, and this here is the modulus of just x. And we have different strategies for sketching those two functions. Okay, so moving on to the examples. What you probably want to do is make that nice clear subheading in your book, and then we are going to write question number 1. So f of x equals x plus 1 squared minus 3. Okay, so we have a function to sketch. Now this is a positive x squared function, so it's happy face. It has a turning point from the completing the square function of minus 1, so we change that one, and then minus 3. So this part 1 is just a sketching question. However, what it also is it could be a graph transformations question, because it's actually starting with a base function of y equals x squared. And then this moves it as a translation of 1 to the left, and this is a translation of 3 down. So that's actually where my turning point comes from. But for now, we're just going to sketch it as we know how to. So, my turning point. And it says clearly stating the turning point. So minus 1, minus 3. Okay, B says sketch y equals f of x minus 1 plus 2, clearly stating the turning point. So what we've got is we've got inside the brackets first, so number 1, we have a translation 1 unit to the right in the x direction. And then outside we have a translation plus 2 in the y direction. So the turning point was originally minus 1, minus 3. Now the x coordinate gets plus 1, so that's now 0. And the y coordinate gets plus 2, so that's now minus 1. So my new turning point is here. And using those coordinates help us to sketch these transformations. So that is our new turning point of 0, minus 1. And I would always advocate using the coordinates, because it's easier often to translate the coordinates than it is the whole function. Okay, part C says sketch y equals 2, all of that, minus 1. Now this is a slightly different way of asking the question. Now what we just need to check is we just need to check what our original function was. And we're just going to check that that is exactly what is in here. So what that means is our original function is just being translated. This isn't a new function, it is still a translation. So we're going to follow BIDMAS first. So the first thing here is this 2. So number 1, that is a stretch. It's outside the brackets, so it is in the y direction. And then we have a translation. Here, that's outside as well, so that's minus 1 in the y direction. So again, I'm going to think about my turning point. Now the x-coordinate actually doesn't change. Both of these are y transformations, so that stays the same. And then we times it by 2, so that's the first step, and then we minus 1. So that's my new turning point. So sketching my function, my new turning point is down here. So the function is just stretched like so. And it's just important there that we remember that we're following BIDMAS, so we do it in that order. Okay, so summary. Always follow BIDMAS. And always use the transformations on the coordinates. And that will help you to understand the transformations that's going on with the function. And the final thing is that the transformation could be f of x plus 2, or it could be y equals x plus 2 squared plus whatever. So you could be asked it in different ways. You could get it inside the function, or you could get it in the actual equation itself. So you need to be able to recognise both of those. So that's our summary box. So put a big red box around that, make it really clear, and then we're going to move on to the practice questions. Okay, practice questions. I would suggest doing these somewhere away from your notes. You want your notes to be nice, neat, clean, separate. So get another workbook or another sheet of paper. Now, if you get stuck on this, that's fine. Come back here, look at the videos, rewatch what you've done before, or you can see the solutions as you go. But try and do them on your own first, see how you get on. If you need help, you can always get in touch as well. So here are the answers. So question A, the graph of f of x is shown. Sketch on a new set of axes the function y equals, now we have a whole modulus here, f of 2x plus 1. So there's actually three things happening here. And we're going to do what's inside the brackets first. So number one is we're going to look at this because that is the multiplying, so the BIDMAS. Now that is a stretch. It's inside the bracket, so it's in the x direction, and it's actually scale factor half. Then number two, what we have is we have a translation. That's still inside the bracket, so it's x, which means it's minus 1, so it's that way. And then finally we have the modulus. Now remember what we said about using the coordinates. We're going to use the coordinates here and see how we get on. So we have three coordinates. We have 0, 0, we have 2.40, and we have 2 minus 64. And we're just going to treat each of those individually. So number one changes the x coordinates scale factor half. So this one doesn't change. This one gets halved. And this one gets halved. But it's only the x coordinates. Then we have x minus 1. So the x is all going minus 1. And then finally we have the modulus. Now the modulus we're going to look at when we have our function. But the modulus essentially just makes the y coordinates positive, so it's going to change this one. So sketching my function. So my new coordinates, this one is now minus 1, 0, so that's here. This one is now 0.20, so that's there. And this one is now 0 minus 64. So 0 minus 64 is down here. So my function is going to look like this. And I'm going to dot here because it's below. And then it comes straight back up. So you can see it's been squished as well as moved. And then because it's the modulus, this goes up instead. So that is 0 plus 64. This is minus 1, 0, which we've got there. And this is 0.20, which we've got here. So we've got our 3 coordinates and we have transformed our graph. Okay, question 2 says sketch the function y equals minus f of x minus 24. So what that means is the translation number 1 is this one here because that's a multiplication. So as a reflection, it's outside, so it's a reflection of the y coordinates. And then 2 is a translation, it's outside, so it's y again, minus 24. So we're going to look at our coordinates again. Our initial coordinates were 0, 0, 2 minus 64, and 2.40. Okay, so reflection of the y coordinates. So y's change value, but the 0 ones stay at 0. Okay, then number 2, translation down 24. So 0 minus 24, 2, and then minus 24 from this. So they are our new coordinates. So our coordinates are 0 minus 24, 240, that's 2, and then 2.4 minus 24, so down here. And the whole function has been reflected. So, and then I'm going to do a little mini sketch of what's actually happened, because often this makes it easier as well. So the first thing that's happened is it's been reflected over, so it's done this, and then it goes that, and then the whole thing's been moved down. So it's going to look like this. So it comes up, and then shoots straight up here, and then comes straight back down again. And here are my coordinates that I started with. And these are always the ones you're expected to label. You're not expected to find this coordinate here, but only the ones that you had to start with. So that's 2.4 minus 24, 0 minus 24, and 240. So you just have to be really thorough with going through stage by stage. Question 3, sketch the function y equals 0.5 f of x plus 3. Okay, so we've got 3 things here, and again we're going to do the modulus last. So we're going to start with this one, which is the multiplication. So that's outside the brackets, it's a stretch in y, scale factor 1/2. And then we have a translation, also in y, plus 3. And then we have the modulus of just x. So thinking about my coordinates again, 0, 0, 2 minus 64, 2.40. So number 1 changes the y, scale factor of 1/2. Zero stays 0. Number 2, the y coordinates plus 3. And then number 3 is going to be the modulus, so we'll do that at the end. Now, again, remember what another option is to start with our initial thoughts. So this one, y scale factor 1/2, just makes it less extreme, and then it's going to go up, something like that. So let's start with this on a graph. So my coordinates are 0, 3, 2, minus 29, and 2.43. Now remember, we are doing this as the modulus, so we need to sketch everything that is on this side of the axes. So this goes down like this, and then comes straight back up. And rather than what would normally happen, which is this, in fact, this whole section is reflected. So we have some extra coordinates to label. Now again, remember, we're only labelling the coordinates they've given us to start with. So that's minus 2, minus 29. And that's minus 2.43. So there is our entire function, and we've done the modulus as well. So a lot of this depends on your understanding of sketching functions to start with, but also just thinking about taking it step by step by step and just remembering what order you're doing it in. But I think doing the coordinates like this is really important, particularly because you can then label all of the components that you are required to for the question. So there are some NEPs on modulus if you'd like to go back to that. There's plenty more on the website www.stutchfield.com, so head over there if you are interested in a few more of these.